So this question here is question number 15 from phase 5, alcohols, phenol ethers, exercise 1. So we have been given with a question which is based on stoichiometry, but the organic compound involving question. So neutralization of 30 grams of a mixture of acetic acid and phenol. So we have acetic acid, we have phenol here in the mixture. So the mixture is made up of phenol and acetic acid. Total mass of the mixture is given as 30 grams. And this particular mixture required around 100 ml of 2 molar sodium hydroxide for neutralization. That is the information given to us. So when we take the number of moles of NaOH required for neutralization, it is given by mass into volume by 1000. So what is the mass? Molarity into volume by 1000. Molarity of the solution is 2. Volume taken is 100 divided by 1000. So total 0.2 moles of NaOH is required. So according to the given statement, 0.2 moles of NaOH is required for neutralization of the mixture which consists of acetic acid and phenol. Now the next statement says that when same mixture was treated with bromine water, 33.1 gram of precipitate was formed. That is another statement what we have to consider. Now the mixture has acetic acid and phenol and the reaction is with bromine water. The reaction is with bromine water. So now we all know that bromine water reaction is possible for phenol, not for the acetic acid. So I have taken here phenol. Phenol is reacting with bromine water. So as to form what? Tribromophenol here. 2, 4, 6. Tribromophenol, which gives you a white precipitate. Okay, now when we measure the precipitate, mass of the precipitate obtained was 33.1 grams. Okay, so it was obtained as how much? 33.1 grams. That is the obtained mass. So we have to do the stoichiometry. I have taken the molar mass. Molar mass of phenol is 94 grams. Tribromophenol will have a mass of 331. So when we take that, so if 94 grams of phenol can produce 331 grams of tribromophenol, how many grams of phenol will give us? 33.1. That is our calculation which we have to do. So mass of phenol present in the mixture will be equal to X can be equated to 33.1 into 94 by 331. That would give us 9.4 grams. 9.4 grams. So how much is the mass of the respective phenol present in the mixture? 9.4 grams of phenol is present. So then when we take the rest of the question, we are asked about the mass percentage. So when we take the mass percentage into consideration, to do that calculation, we need to understand how many moles of this acid, how many moles of the phenol is present. So let's calculate the number of moles of phenol. Number of moles of phenol, how do we get? First lesson of stoichiometry. Mass by molar mass. Mass by molar mass, that is what we have to do. Mass of the phenol we got is 9.4. Its molar mass is 94. So how many moles is it? 0.1 mole. It is 0.1 mole. Total number of moles of NaOH which is reacted is 0.2. And phenolic number of moles is 0.1. Both phenol and acetic acid. They are monobasic acids. So automatically it accounts to us that the number of moles of acetic acid is also 0.1. Okay, so number of moles of acetic acid. Number of moles of acetic acid is also equal to 0.1 mole because total number of moles of base reactant is 0.2. Already phenol is contributing to 0.1. So acetic acid will contribute to 0.1 mole. Now if we want to calculate the mass of acetic acid is given by what? It is given by number of moles, that is 0.1 into its molar mass, which is 60. So it is equal to 6 grams. Is equal to 6 grams. So when we take the respective mass of the phenol and the acetic acid, what did we get? We got 9.4 grams of the phenol and 6 grams of the acetic acid. So now let's calculate the mass percentage of these two. So mass percent of acetic acid, mass percent of acetic acid is 6 by 30 into 100. That would be around 20%. And then mass percent of phenol is equal to 9.4 by 30 into 100. That would be around 31.3%. So this is how you solve the question. Thank you.